Welcome to this afternoon's session all about the ArcGIS Runtime SDK for .NET, building apps. My name is Mike Branscomb. I'm one of the product engineers on the team that builds the ArcGIS Runtime SDK for .NET, and I'm joined by Morten Nielsen here as well, the lead dev for the SDK that we call the .NET SDK. The session this afternoon is all specifically about the ArcGIS Runtime SDK for .NET. You've heard a lot at the conference already this year about ArcGIS Runtime 100, the new architecture that we've employed and re-engineered in the ArcGIS Runtime 100. And the session structure this year at the Dev Summit mirrors that architecture. So we've got a series of sessions specifically about the SDKs, and then we've got many more sessions about functionality that cuts across all of the ArcGIS Runtime SDKs. So a big part of that re-engineering effort was to implement support for maps and layers and routing and analysis in the ArcGIS Runtime core, and that means all of those features are available in all of the ArcGIS Runtime SDKs. So the session this afternoon, we'll take a look at an overview of what the ArcGIS Runtime SDK for .NET is, a look at the architecture as well, how we build the .NET SDK, how it's exposed to you in a public API. We'll think about working with the SDK and take a look at how you work with the SDK, highlighting some of the changes perhaps between the 10.2x generation and the 100 series. Also take a look at local server, which is a component of the ArcGIS Runtime SDK for .NET, and some of the changes there as well in terms of how you work with the local server. Then we'll take a look at Xamarin as well as a specific new feature, a highlight in the new version of the ArcGIS Runtime SDK for .NET, and some online resources and a roadmap for the future as well. So an overview then. The ArcGIS Runtime SDK for .NET is all about building native apps for Windows, native apps for Android, native apps for iOS, apps that run on your device. So you build the app, you're working with our ArcGIS Runtime.NET API. I talked about the new architecture of the ArcGIS Runtime 100, and it really focuses on that ArcGIS Runtime core that's available to you through the .NET API. All of that functionality, you make calls down into the device, great support for native capabilities of the platform, whether you're working on Windows, Android, or iOS. But also the ArcGIS Runtime provides great support and integration with online workflows as well. So identity management, working with online services, working with your WebGIS, whether that's in ArcGIS Online or within your enterprise as well. So more specifically about the ArcGIS Runtime SDK for .NET and what we consider to be an SDK. I've talked about the ArcGIS Runtime core, the ArcGIS Runtime.NET API. The SDK also comprises a toolkit as well, so components and utilities that we make available to you as an open source toolkit on GitHub. That's very much part of the SDK. It's a supported part of the SDK, but we open source the code to you on GitHub and to allow you to work with it in a richer way to customize it for your needs. The SDK also comprises an API reference as well, so we spend a lot of time writing / comments in our code that gets compiled to API reference. We host that, obviously it's available to you within Visual Studio Experience in the object browser, but also we host that online in our developers website that you can browse and find out information about how each API type specifically works. As well as that API reference, we also provide guide documentation. So that's conceptual documentation about fundamental patterns and practices, layer types, how to work with maps, how to release and deploy your app, how to license your app. So lots of great information in there. Samples and demos as well. We've got GitHub repos for samples that specifically show how to use the API types in a very focused way, how to work with a map, how to open a map for a portal, how to save a map, but also demo apps as well, so more fully featured, larger applications that show how to build apps with the API in different kinds of workflows. It might be routing, or it might be editing, or 3D. ID integration as well, so the SDK comes with ID integration, integrates into Visual Studio. That's available to you whether you're using NuGet as a way to reference the API, or maybe as a Visual Studio extension that you install downloaded from the ArcGIS developers website that includes a series of project templates to help you get started quickly with your applications. And then finally, the SDK includes the community. So that's all of you folk, plus us as well, interacting in GIS Net at the conferences, exchanging in discussions, really kind of building the community and helping you out in GIS Net and the forums. So what's the ArcGIS Runtime SDK for .NET version 100 then? Well, it grew out of the 10.2x series of ArcGIS Runtime SDKs. So there was a re-engineering effort that went on at that ArcGIS Runtime core level to re-implement some of that functionality and expose it in a way that was consistent across all of the ArcGIS Runtime SDKs. What we were trying to do was minimize the amount of code that each API had to write specifically to call into those core functions. And that, one of the great benefits of that is that that functionality is implemented in the core and then it's exposed in all of the runtime SDKs consistently and together at the same time, and also much quicker as well. So we released 100. Since then we've been working on new features and they're coming online really quickly. We've got an update coming out, or a couple of updates coming out this year that you'll see additional features rolling out much faster than we could have done previously with the 10.2x series. So the ArcGIS Runtime SDK for .NET version 100 includes a number of APIs for building native apps. WPF for Windows Presentation Foundation. Universal Windows Platform Apps, a UWP API for building the new Windows 10 Universal apps. Also APIs for Xamarin Android, Xamarin iOS, and then also Xamarin Forms. So we're supporting Xamarin Forms on top of Android, iOS, and UWP. So it's a really great SDK for you to work with. We've moved beyond the Windows realm onto Android and iOS, so it's the best cross-platform SDK that we have. Of course I'd say that. And one of the great benefits about being a cross-platform SDK is, still gives you the ability to use the native UI framework on those devices, so taking full advantage of being a native app on Android, iOS, or Windows. And then also I talked about Xamarin Forms being it's actually an abstraction layer that allows you to share more of your UI logic as well as your business logic across those platforms. Okay. I'll now hand over to Morten, who's going to talk a bit about the architecture.
Right. I just wondered, how many here have not heard about Xamarin? Well, I'll go over this really, really quick. It came out of Mono. Microsoft bought Xamarin last year. It allows you to use .NET code, C# code against the native APIs. I think pretty much most of it is here. Mike already touched a little bit about it, that most of your business logic can be shared because you have all the standard .NET libraries available to you. Since you all already know this, I'm just going to move on. However, I don't know if you guys saw this thing. Visual Studio 2017 launched a couple of days ago. And they said if you download Visual Studio 2017 before March 14th, you get 60 days free access to Xamarin University. It's a really, really great resource for online training. Lots of in-depth classes about how to use Xamarin. It's actually pretty expensive to get access to, and really all you have to do is just hit the download button. You don't even have to install it actually. And this offer pops up and you can sign up for it. Really great to take advantage of, but you have to do it before March 14th. So just a little tip there. How many here do not really know what the Universal Platform is? Everyone has already heard about Microsoft's new Windows platform? That's amazing. It's amazing. I'm really glad. But again, just to recap, it's this new one core. It runs everywhere. It runs on my Windows PC. I have a little cheap tablet. I have a phone. There's a HoloLens. I have a little IoT device here. The Windows runs on all of them. And the same core, and that actually means the same binary you build on Windows Universal will run on all these devices. And if new devices comes out in the future that we don't know about, there's a good chance that the runtime will run on there too, because we don't have to do anything. So here's an example of some of those devices and what they look like. Raspberry Pi, you guys play with those. Xbox, it'll run on Xbox. But I kind of want to go a little bit into the depth of how we build this, because I think it also tells a good story about how you can build your apps on top of it. So of course you have your operating system on the 4 different platforms. There's Windows, there's the Windows runtime inside Windows for the Universal. There's iOS and Android, of course. And on top of that, we have this C++ core that Mike was talking about. This is where all the meat is. This is where all the fun is. And we build on top of that, we actually write one common set of .NET code that calls into this. So the yellow and blue code is completely shared from our point of view. The C++ team sharing their code as well for cross-platform C++ code. So it is literally the same code all the way through. There's hardly any differences for the way we implement things. On top of that, the UI stack on the different platforms are actually a little bit different. So if you use XAML on Android, you use AXML. iOS, you can use like storyboards, and the UWP has its own version of XAML. So we have a small piece of the API that is different from platform to platform, and that's the UI. It means the map view control. And that means that's the part where you might not share code. But all the stuff in the blue box is where you share code. So that means all your business logic can be shared across LSE. You have to learn the SDK. It's the same thing over and over. However, if you don't want to do that, we have Xamarin Forms. Xamarin Forms is an abstraction of UWP, iOS, and Android. It does not at this point support WPF. But it allows you to write XAML on all these platforms and share that UI across all of them. So it's a write once. It can be a little bit of a least common denominator sometimes. So if you're really about pixel perfect and really feel native to each platform, Xamarin Forms might not be for you, but if you have to get a quick app out at a really low cost, it's a really great option for something like that. There's pros and cons, and it's constantly improving Xamarin Forms. And the last Visual Studio 2017 added a bunch of extra really great support for it, like designer support and those kind of things. All right, so here's really this is how you really should think about it. There's the core piece that's really all black box to you, but there's the big giant blue box. That's where you write almost all your code, and then a little bit of UI code, unless you're using Xamarin Forms, and that can also be shared. So let's get started. Let's do something. How do we get started, Mike?
Okay. Well, actually, the great news about working with ArcGIS Runtime SDK 100 is that no install is necessary to get started. So all of the APIs have been published as NuGet packages on NuGet.org. Easy to find. You can just type in esri.arcgisruntime as your search term on NuGet.org, and you'll find all of our NuGet packages for the APIs. That means WPF, UWP, Xamarin Android, Xamarin iOS, Xamarin Forms, local services for local server, toolkit. What else? Any more NuGet packages?
Well, I think that's about right.
Okay.
Yeah.
So lots of NuGet packages, and they work directly within Visual Studio using the NuGet package manager, so install straight into your solution or into your project. But we do also provide a Visual Studio extension that you can download as well, so you can log on to the ArcGIS developers website with your developer account, download the Visual Studio extension, install that into Visual Studio, and that does provide some simple project templates for each of those APIs or each of those project types. The Visual Studio extension is actually interesting because it includes the NuGet packages. So rather than have two different mechanisms for providing the API to you, one online as NuGet, one local as some other referencing system, we've made them included them within the Visual Studio extension as NuGet packages. What the extension does is create a local NuGet source. So within Visual Studio, you'll see an Esri NuGet source, and you can reference the NuGet packages from that local source. I said that the Visual Studio extension contains the simple project templates. There's actually a separate NuGet package now for local server as well, so that's a slight difference from the 10.2x generation that we'll talk about in a minute. And also the open source toolkit. So the open source toolkit is compiled as a NuGet package or built as a NuGet package. It's on NuGet.org. We released a beta earlier this week for the 100 API, so you can go out and take a look at that today. It includes already a compass, a legend, table of contents, a sign-in dialog on WPF, feature data field, or feature field, and a scale line control as well. Right now that's available for WPF and UWP, and we'll be adding NuGet packages online with Xamarin support as well soon. So I talked about downloading the SDK from the developer's site. That's your point of entry into the ArcGIS Runtime SDK for .NET. The toolkit source is on NuGet in a GitHub repo. The samples as well are in a GitHub repo, as are the demos as well. And then there's some other resources as well for helping to get started with the SDK. The new developer labs that were talked about in the plenary earlier this week. There's a .NET section with 3 developer labs written in .NET that build on top of the same data design develop workflow as the other labs. And then also high-level docs as well. So actually one up from the .NET SDK on the developer site are a series of high-level docs. For example, working with web maps, working with web scenes, licensing, information like that you can find at the high level on the developer side. So I'll hand over to Morten now to take a look at building our first app.
Thanks, Mike. I actually got a surprising number of questions about support for Visual Studio 2017, which was released 2 days ago. So I figured let's live on the wild side and actually do this demo in 2017 and see if it works. One thing that won't work is the template integration that Mike talked about. So you will not see, if I go file new project here in 2015, you should see some of these project templates. And these are just starter templates like from the ArcGIS Runtime app. So these will be integrated into 2015, currently not in 2017. The next update will have that. Sorry we didn't re-release in the last 2 days. We've been slacking with the conference. So that's not in here, but I'm actually going to start blank because I want to show you to get set up. So I'm just going to start a new WPF app. This looks just like 2015, so don't really worry too much about that bit. And we call it maybe devsum, whoops, caps lock, devsum demo. And so I'm using WPF right now. Pretty much all the code you will see will work on all the different platforms. The markup for UWP might be slightly different. It'll be very, very similar to Xamarin Forms markup, and if native Android UI and your iOS UI will be quite different, but again, all the code that I'm actually writing will be the exact same thing. So all of this applies. So let's first get NuGet add. So normally you would go in to add references, but there's another one that says manage NuGet packages, and that's actually the one you have to go into now. It's not in the add references. So I'll go into there. And I can just say browse, and I'm going to say, actually I can just click in the drop down. If I install the SDK, I will have an Esri section right here. And I can click that, and it'll show all the packages that were installed. And when you get version 100.1, when we release that, you will be able to still pick this and then pick different versions. But right now, I couldn't want only one version installed. But I can also go to, if I didn't install it, I can just search for the package name, and here they are. In this case, you'll actually see 10.2.7 is also listed over here. So that's how all you have to do is just click install, it goes and downloads it. You will notice though, the toolkit says version 10.2.7, and Mike just said we released a new version, which we did, but it's a beta, so you have to check this little thing up here. It says include pre-release. And once I do that, now toolkit actually says 100.001 beta 1. So that's how you get that. So just a little FYI, it might look a little hidden at first. You will also see a bunch of specific packages for each platform. Technically, you don't really have to worry too much about that. You can just take the top one here. This will pull in the right platform dependencies, and you can see in the dependencies that if you're doing WPF, it'll take the Esri ArcGIS Runtime WPF one, and if you do iOS, it'll download that one. It won't download all of them, just the ones that your solution actually needs. So that's actually the easiest. This one is actually not, we just released this one that points to all of them. It is not in the setup today, so there you would have to go and pick the WPF one. I'm actually going to cheat. I'm just going to add the toolkit one, because that would actually point to the WPF one and also install all that cascading installs, which is really, so you can see here, oh, I'm going to install toolkit WPF, and the WPF bit. So it's smart enough to figure out the dependencies. I really just have one dependency that then cascades to all the other ones. So it'll actually go and download it, so it's finished. If I now click on my references, I now have it here. That's all I had to do. So I'm just going to hit a quick little build, make sure things looks good. It should. And I'm just going to open the folder, and I'm going to show you what happens. So here's my app. There's the runtime, there's the toolkit. But it will also install, these are all the language resources, but there's also an ArcGIS Runtime 100.1 folder. This is what you used to actually have to go through a deployment tool to do. The build script now does that for you. And there's a 32-bit folder in here for the 32-bit DLL. And then the question is, why didn't you support 64-bit? Where's the 64-bit DLL? We do, but this app is not a 64-bit app. And that's something to be aware of. When you do a WPF app, it is actually not a 64-bit app by default. There is a little thing in your project setting that says prefer 32-bit. And we're smart in saying, oh, you're making a 32-bit app. Why would we deploy the 64-bit app? So it's trying to be smart about that. So I just uncheck that and hit build. And now there's a 64-bit folder as well. So it's smart enough to not do that. Or if I make it only 64-bit, then it doesn't install the 32 one. So just beware of that. All right. First bit I'm going to do is something that's technically not necessary, but it is a good practice. I am going to initialize the runtime. Do that this first thing when the app launches up, initialize it. If you don't do that, when you start calling into the API, this will automatically happen. But sometimes if this, for instance, the code that the binaries that got deployed, something is wrong with them or didn't get deployed for whatever reason, or you pointed to a different installed folder for that's not there, then you can get a very, very obscure error. For instance, when it starts to parse the SAML, it's a SAML parsing error because it couldn't figure out what the control was because it couldn't find an initialize correctly. So it's a good thing to always put this initialize call in here because then you get the error right there before it's doing anything else and it'll tell you exactly what was wrong. Oh, another thing that could happen is we require the Visual C++ 14 libraries to be installed. That's a system requirement. We do not deploy them for you. So if you sometimes go to deployment on a machine that doesn't have that installed, that would actually crash with an error telling you that. So this call would actually also throw right here and say that there's dependencies missing. All right, let's write some code. So I am just going to go all SAML here, and the first thing I will do for those who've used our API before, it's pretty standard. We register our namespace. I'm just going to put in a little map view. So yeah, I see all my toolkit controls here. It's kind of neat. And let's call it map view. I'm going to set the map to, I'm actually just going to use some MVVM style coding. So I'm just going to bind to a map property that we'll create in a second. And I'm getting a funky squiggle that doesn't mean anything right now. That happens once in a while for me on this machine. Anyway. Let me just quickly create a little property here. So I'm just going to cheat and put all my usings in. So I'm declaring a map property, and I'm just going to create a new map with the streets night vector base map. And I'm going to zoom in on, this is actually going to be at the conference center as a starting point. I'll just set the data context to this. It's not the, actually let me set it to the map. We'll take this off. It's a little prettier maybe I'm like. And let's run the app. So you could declare the map in markup as well. I like to do it in code because I feel like the map is a model object in a sense, and that's the one that I work with. There might be one I'm creating from Portal and get it that way. And there you go, there I have my first app. This is the nice vector map. Can I expand the window like that? It's quite dark on this map. Maybe we should change it. That's very easy. Create, how about the streets vector instead? That might be a little easier to see on these screens. There you go. Cool. Well, that's fun, but not that interesting. Let's create, let's actually pull in a toolkit too while we're at it. I'm just going to add a little compass control here. And the compass basically just shows what's north. And you can set the heading to any number you want, but the clever thing is I could just set it to the rotation value of the map view itself. So I just bind straight over to the map view. And so if I run this, we should now have a little toolkit control as well. it's gone. You don't see it because it's clever. It's when I rotate the map, it pops up in the corner. You guys can see that up there? Let me, right up there. If I zoom back to north, it disappears again. That can be turned off. There's a property for auto hide that you can just turn off, but it's a nice little experience. You can write code. Just, if you tap it, for instance, it resets the back to north. It's a nice little gimmick to have. Anyway, I do want to write a little more fun map, so I'm just going to copy a little bit of piece of code in here, and I'll explain this in a sec. That wasn't right. I'm cheating a little here. So I have a map instead, a little more advanced code that sets up a whole map for me. Let's change this to the streets again, like that. So this is basically the same piece of code, but then I created a new thing we have is called the feature collections. And these are, you've probably already seen these in a web map and online. And I created a dynamic table on the fly, and I'm just adding a text field here. That's a point layer. Assign it a renderer. I'm gonna make this circle, for instance, color red, so red dots. And I'm gonna add that to the map's operational layer. So we have a base map and we have operational layers. The base map goes into a little more optimal rendering performance mode for those, so it's good to actually not just put everything in operational layers, but keeps the ones that you kind of want to operate on. It gives a nice separation between what's just the base. If you want to switch out the different street maps, for instance, that's a great way to separate them, because you can just assign a new base map and have a base map picker that way. The next thing I want to do is I want to be able to add something to my table, so I'm just going to do the simple thing and have a click event or a tab event. If I tap the map, I am going to create a new feature in here. So I'm going to grab the first feature collection here from the table. I'm going to create a feature from the table, assign the geometry to where I clicked, set the attitude. In this case, I just set the text of the location, but it could be anything. And I get a squiggle here because adding a feature is an asynchronous operation. And to await that, I have to actually declare that my method is async. Beware when you do async voids, that's kind of a no-no, because it could really bring down your app if this add fails. So it's also, if you're forced to do an async void, it's better not to, but if you're forced to, which I am because it's an event, I can't get around making this a void method, it's a good thing to have a catch, and then maybe it has some error message to the user here. So async await makes writing multi-threaded code super easy, but it doesn't make multi-threaded easy. So there can be some caveats with that. So at least catch it, and whatever error will come back here on the same thread. Cool. Let's see if this works. So we're actually creating an in-memory feature layer that I can now modify. Boom, like that. We have points we can add, so on and so forth. But it's not really that interesting, because I shut the app down and launch it again, all this is going to be gone. How do I persist this data? And feature collections are neat because they can actually be part of the web map. So if only I could create a web map from this map, wouldn't that be nice? So let me try that and say if I close it, maybe let's try and close my app. I can just serialize the whole map to JSON and write it to disk. So I just write it to a file called map.json and put it in. So if you have 100,000 features in a feature collection table, this is not a very good idea. It becomes a very, very large JSON object. But for just a little bit of data that you want to store or rehydrate this way, this is a really neat way to do it. And then the only thing we then have to do is when the map launches again, instead of creating a new map, we could just say, hey, if that file is already on disk, let's just read it in and return that map instead. So the first time this file doesn't exist. So I'm going to add a couple of points. Like that, I'm going to shut down. I'm going to start again. And there they are. Pretty neat. And if let's look at what's inside here. Here's the map. Let's open that up. There's all the GIS. This is the entire map. This is a standard Esri web map that can be shared with anyone. I put it on disk right now, but it could be opened by the JavaScript viewer. It could be opened by another runtime. It could be opened by a pro, including these feature collections that are in here. So let's actually do that. Let's make this available to other people. So I'm going to first add a little button to my app. I'm going to say, let's publish this map. I'm just going to put a button here. It says, when you click it, let's publish this to the portal for sharing. It's surprisingly easy. So I'm just explaining this code here. There's, I'm setting up a portal I'm talking to. In this case, it's just the standard ArcGIS.com portal. And I'll skip over this, I'll come back to this bit. But the first thing I want to do is, to publish something to the portal, I have to have a credential. I have to be signed into the portal as a user. An anonymous user can't publish maps. Because if you normally just create a portal without a user, you will get an anonymous user. But if you force a portal creation with a credential, then you're that person. So I'm just going to use our authentication manager's challenge handler to reuse that's built into the system to actually generate me a token for a certain user. So once I have the portal, which I create, really all I have to do is save with the portal, Dev Summit. We should probably give it a better tag or description. Let's do, how about doing date time .now, so you can see this is not fake. I have to specify a few tags, optionally a thumbnail as well. And that's really all I have to do. Now, the moment I do this, the map will be associated with the portal. And a map has an item on it. In this case, it's usually a portal item. So I could check, well, if it already has an item, just call save. I don't have to do all that other stuff. And it automatically goes up to the portal and saves it. And if I don't have an item, well, I guess I have to create a new one. I have to call save as instead of save. If I were to call save on a thing that does, or save when it doesn't have a portal item, so you're able to throw and say it's like having like a no file name for a file. You can't save it until you define the file. So that's pretty standard. Yes, so let's try that. And by the way, here is my current content in my portal. I haven't done maps since 2015, apparently. Let's add some more. And this is publish to portal. Oh, I forgot something. I do not have a challenge handler because it's not out of the box, but it's with the toolkit. The toolkit provides a challenge handler you can grab and you can change it to your liking. If you don't like the UI or experience, but we provide a generic one that handles all the authentication methods we know of. So really, I just set it up with an authentication handler. It needs to take the UI thread it should be calling back on because it has to pop up a UI. And often the challenges might come on a background thread. You can also write your own that also always returns the same username password if you just want to hard code something in. Probably not best practice, but it can be done really quick and simple. It also provides you a way to store your credentials into the credential manager. So if I ask again, oh, there is my thing, I'll log into my, I get the option to click here, so when we do the demo again, I don't have to do it again. And it should now publish. Let's go over here to my content. Refresh, there it is. Dev Summit 2017, that's pretty easy. And hopefully, my data is in here. There's the date time, it looks about right, that it wasn't fake. And with a little luck, there's my dots. One thing I did forget, I did not set it up for saving its the location that I was at. So it might be a good idea here to say map initial viewpoint is, I'll just grab the current one, get initial viewpoint, or current viewpoint. I'll just use the current bounding box, and that way the portal can associate a viewpoint with it. The initial viewpoint is actually not part of the web map. So when I save it to JSON, it wouldn't actually remember that. But the portal item consists of two things, the web map and metadata about the web map, and it goes into that metadata. And then when we call save here, it's smart enough to also take that and put into the item itself that's outside the web map. So if I were to do this again, I should probably delete this map. Come on. Just going to delete. I could have just opened it from the portal, but instead of from disk, right now I'm reading it from a disk, but if I do something like this, add some more dots, we'll hit publish again. Look, it actually remembered my credentials from last time. That can be turned off in the challenge if you don't want that kind of functionality. And let's go back to my content. I'm gonna refresh. And open. So the time step changed, if you noticed. There we go, right where I left off. Let's add some more along this here. And I can now, because it already had an item associated with it, and I just click publish now, it's not creating a new web map. So if I refresh here, we should see those dots. There you go. Pretty neat. Feature collections are a new functionality that wasn't there in 10.2. It's been in the platform, and we had a way to convert them into graphics, but there's no really good way to put them back and publish them. The feature collection can also by itself be published to the portal, so it can be reused in various maps. So that takes all that data out of the map and into its own thing. It's not a replacement for feature services. They have each their pros and cons. This is really neat for just sharing a quick little bit of data or a data result that you want to share with others. There's another reason, if you have a map that might suddenly be featured by CNN or something and goes viral, feature collection can actually be more efficient than a feature server, because if they all make the same query to get the same 100 features or something, there's no reason to have the huge overhead of doing a SQL query and seal into JSON, because the feature collection is really just a dumb JSON file on disk that's being served out. So it can actually help scale really well for these when you suddenly get 1 million requests for it, so your feature server doesn't get bogged down, because you just have to serve up a pre-generated, basically it's the equivalent of a query result that's just pre-generated and saved to disk. So there are some nice benefits for having things as a feature collection that way. So yeah, I think that concludes my demo for building your first app and getting portal, feature collections. Those were the new few things we had. Mike?
Excellent. Thanks, Morten. Great demo of building our first app there. Now let's take a look at using the local server. So the local server is a component that's available to use with the ArcGIS Runtime SDK for .NET. One of the things that we're promoting it for is for use as a way to provide geoprocessing and analytical capabilities with the ArcGIS Runtime SDKs. So it's specifically available for the Windows and Linux platforms. Working with .NET, that means it's available with the WPF API. It's the local server SDK itself is also available for the Java and Qt SDKs. One of the changes from 10.2 is that we don't bundle it in within the SDK. So the Visual Studio extension that I talked about downloading from the ArcGIS developer site doesn't include the local server. It's a separately available component now. So I've got a WPF application in front of me here. You can see the XAML and the map view. If we switch to the NuGet package manager for this solution, you can see that I've already referenced the WPF NuGet package here. But what I also want to do is reference the local services package. So the API for actually working with a local server and working with local services within the .NET SDK is a separate NuGet package. That means in here, if I search for local server, and switch to the Browse tab, then I see the local server NuGet packages. So Esri ArcGIS Runtime.local services is the NuGet package for use with the WPF API and for working with local server. So I can install that to my project here. And we pick the version 100. I should obviously view the license, so I understand the licensing, understand the Esri license terms for this, but I'll just accept the license and install that NuGet package into my solution. So we can see that successfully installed the local service. If I switch back to the installed tab now, then we see the WPF and the local services NuGet packages are both installed into my solution. So I can jump over to my map view model and actually start writing some code against this if I want to create a local geoprocessing service. I can just instantiate a new local geoprocessing service there. That string that it wants, that would be the path to a geoprocessing package created within ArcMap. So actually that's how I start working with the local server and creating local services. If I was to build this solution and just check that I've written my code correctly, I actually get a build warning down here. So we can see that it tells me the ArcGIS Runtime local server SDK is not installed. So although I've referenced the NuGet package, I actually need to download the 1.5 gigabyte ArcGIS Runtime local server SDK that includes all of the local server functionality. Well, I've already done that, in fact. So what I'm just going to do is jump back to regedit and rename this registry key. So I faked up the fact that I didn't have the SDK installed. And if I rebuild, that builds successfully. And I'm actually able to now start building an ArcGIS Runtime SDK for .NET WPF application with local server functionality. Now, Morten talked in his demo about how the NuGet package is automatically, and the referencing system is automatically building the deployment for you within your output folder. If I take a look at the output folder for my project now, we can see that ArcGIS Runtime 100 folder in there contains the same content that you saw in Morten's application, so the client 32 resources folder in this case. But actually, if I go back up one level, you can see that there's also a local server folder as well. So that local server folder then contains all of the deployment, in this case just a 32-bit deployment, but that's built based on the fact that I've referenced that NuGet package and it starts deploying that into my application. If I switch back to Visual Studio and just say show all files, one thing that I can do is actually control what gets deployed for the local server. So by default, it will just deploy the minimum required to host a local map service. But actually, in my case, I wanted to do some geoprocessing. So we can see the manifest file here, and there's a geoprocessing item here. And if I just set that to true, that will start to deploy the local server geoprocessing content as well. And then there are some additional options under that geoprocessing. So some of the extensions, map server results, network analyst. If I want to do some Python scripting, then I would change the Python scripting deployment option as well. And then next time I rebuild my solution, that's deploying additional components into that deployment. Okay, so that was a demo of using the local server component with ArcGIS Runtime SDK.NET, and a look at highlighting some of the differences between the way we worked with it in 10.2, 10.2x versus the way we worked with it in 100. I'd now like to hand over to Morten, who's going to take a look at building Xamarin apps.
Already?
Are you ready?
Not really.
Do you need more time?
No, that's fine. Okay. Yeah, that's fine. Go for it. So there's this great feature that's been rock solid since the beta, and the only time it's failed in my 2 sessions here, right now and my previous session where I did this in, so it's not really being right heavy right now, but we'll talk to it. Let me just change one thing. I am going to set this while before I start. I'm just going to set. No. So I'm just going to do a quick little overview of Xamarin, but I just want to kick this off because it might take a little while. We had a demo theater session for an hour Tuesday, that's recorded. I would recommend watching that. It goes into much more depth about building Xamarin apps. But I just want to give those who did miss that, I want to give an overview of what a Xamarin app actually could look like. And what I have here is, you guys saw the indoor routing app for iOS that was showed at the plenary. That actually grew out of a sample we had that was actually a cross-platform Xamarin app. It was actually Xamarin, but it was only built for iOS. But we do have a simpler version of it in our GitHub repos. And you will see that there are 3 projects down here, one that says Android, one that says iOS, and one that says UWP. These are the project heads that has the specific UI for the platforms, but all the platform code is up here in the business logic, and that's actually where most of the code is. There's code for how to do geocode, how to calculate a route, how to get the data and provision them, what the layers and map definitions, all that stuff is up in this shared code. And so each of these project heads are actually referencing that. And you would see in here, I'll have just standard XAML. For my UI here, it'll be using normal binding to bind to my view model that is up in my shared business logic. For Android, you might see, for those who've done Android before, there's an AXML file, which is this XML format. That for if you don't Android is no different. But we also do provide a Forms version. Come on. And actually here, these 3 projects, as the Android, the iOS, and the UWP projects, are just standard projects. They're just file new projects, and that's all they are. Everything is in the Forms, and what's left there is really just the UI, which is just this little page and a little helper class for doing an autocomplete custom control that wasn't part of the common form set. Really, really neat way to build the app. But I think the coolest thing is, and I think it actually just worked now, is this is an iPhone app running on my Windows device. It blows my mind every time I do this. And to show that it's real, I'm going to go here, and I have a set of breakpoint on geocode. So I'm going to enter Q, maybe receptionist. Boom, I have a breakpoint right here. I can inspect, I can see this is the text. So I can actually do iPhone debugging on my Windows. It is really running on this Mac, so it's sending the app over to the Mac to run the simulator over here, but then it's equivalent of remote desktoping it back. So I can keep my Mac closed the way it's supposed to be and just stay on Windows and not having to touch it after it's set up. It's really, really nice. Similarly, here's the Android app. I can debug the same thing. I'm just going to launch it right now. But it's the same app. The look is a little bit different because I tried to adapt it to something that looked like Android, but I mean the same stuff applies here. Maybe I want to put the auditorium. This app actually provides a nice feature. It's been raining a lot more in California lately, so it actually gives me an alternative route. It tries to optimize indoor and outdoor. Let's see if we get a calculation here. My PC is a little bit bogged down. Let's do it here for, there you go. There's an alternate route, that's the black dashed line. That takes you a little bit of a detour, but it tries to reduce as much time outside as possible. So you just have to run across the street and into a building, so it's a little bit of a detour, but then you don't get as wet. Here's it running on UWP. You can see it's very, very similar, maybe slightly different. I actually think I have it here. Here's a 3D version of it, which just stopped working, but we can also do this in 3D so you can see the changes. But let's try something a little more fun. Because now that I have a UWP version, I have a Windows Phone here. Anyone has a Windows Phone? I thought so. Oh, there's one. There's one. It would run on there, but that's great. I have this little, it's called a Dragon board, Qualcomm Dragon board. It'll run on here, it'll run on Raspberry. But why not run it on this thing? Just because I can, and that's really the only reason to do it, is because I can. So this is the demo that requires very good Wi-Fi for you to see what I do. So hopefully, let's see, online. Let me know if the connection drops. Oh, there you can see. So usually when you turn it on, it starts scanning the room and tries to figure out where am I? Have I been here before? I'm just going to remove this menu. I can kind of click here. And you see there's a scanning going on. And after a little while, it starts recognizing, wait, I've seen this place before. Sometimes it takes a second or two. Hopefully. Because I think I already have the app somewhere in this room. Come on. I was a little quicker earlier, maybe I was a little more around. Did someone move the room around? So you can see it does this scanning where it creates a mesh of the whole room, which makes it able to interact with and put stuff on the walls, have balls roll around down the staircase. Oh, I think it actually figured out. You see how it scans? And whoa, what's that up there? There's my app. And so I can grab here, move it. I think I just managed to put it inside the wall. That was kind of unfortunate. Let's put it somewhere else. Oh, wow, it's far behind you right now. It's still doing the scan? There's my app. Now, yeah, just you have to like have a little delayed voice here. Let me speed this up a little bit. There we go. Now it seems to be about half a second behind me, but I can zoom in, and so it's the exact same app, but I don't have to change anything. So, oh wait, what's that? Oh. It looks like it's a little bit, you've got to watch out there. I think you have a little bit of a thundercloud over your head, and there's a little bit of a T-Rex sitting over there behind the chair, so just be a little bit careful. And there's some of my things. So I can put apps around the room, have them like my virtual desktops. I think it's pretty neat, and I didn't have to do anything to the app at all, other than just deploy it to here. And that's, I think it's a pretty powerful thing about the universal platform, that it just works. Whereas for Xamarin, your code just works, but you still have to build different apps and tweak them for the platform and have a Mac to build the iOS one. That's a really, really powerful feature. Oh, there's one more thing. Actually, I'm not sure do we have time? No, we don't.
We've got 7 minutes.
Don't we have more demos?
And I think that's it for demos.
Well, let's show one more thing, because, I mean, this is a flat app over here. I think I put an app right here. So we don't provide an API for rendering 3D content in the HoloLens, at least not at this point. We can just render the 2D apps, which is not that interesting. But Unity provides a great environment where I can actually write .NET code to write my apps. And I can take my UWP runtime and call into it for at least all the APIs for getting data, for doing geocodes and routing. I'm just waiting for an app to load right here. It takes a little while. Come on. They did not start? No? Where did my app go? Maybe it's behind me. Sometimes you get a little lost. Where did I put it? I'm gonna try and relaunch.
Shall I go back to slides where you find the demo?
Sorry?
Shall I go back to the slides where you find the demo?
Yeah, actually, well, there's the doc, by the way, if you guys are worried. There's. Come on, don't fail me now.
Okay. I'm back on
you
slides.
can back up.
Okay.
Yeah.
Okay, so a couple of great demos about building Xamarin apps and really highlighting the cross-platform capabilities of the ArcGIS Runtime SDK for building for Windows, Android, and iOS, and sharing a great deal of your code across all those three platforms. So let's take a look at migrating from 10.2x to 100 then. There's some really cool things in the 100 version that you couldn't do in 10.2x. So we talked about some of the re-engineering effort that went on to really enhance the internals of the ArcGIS Runtime core, but we also brought out some new functionality in the 100 release as well. One of those things was that cross-platform support with Xamarin, so building for Android, iOS, and Windows using C#. But also direct reader raster data, so directly supporting raster data, multiple raster formats, really great high performance capability directly within the ArcGIS Runtime. And also, as Morten showed in his demo in the building apps section, actually opening maps from the platform, from online, from Pro, and saving those back as well. So excellent integration with ArcGIS Online and ArcGIS Portal. Also vector tile base maps as well, support for these excellent vector tile base maps which give great performance, great footprint on disk, so really small footprint on the device, but also they scale really well on high resolution devices. There's a couple of things that aren't supported any longer. Windows 8.1 store apps and Windows 8.1 phone apps. We're not supporting those any longer with the 100 release. We also support only .NET 4.5.2 and above for building your apps. There's also some notable features on the roadmap. So there were a couple of features in the 10.2x, 10.2.7 release that we had temporarily removed from the 100 release, and we'll be bringing those back in updates this year. So shapefiles, KML, related tables, and time support. They're not in the initial 100 release, but they'll be coming out in updates this year. We've just published a guide document on our ArcGIS developer site about migrating from the 10.2x release to 100. So I encourage you to go and take a look at that if you're going through that process. Licensing model. So there were some licensing changes in between 10.2x and 100. I won't cover all of this now, but there's if you go to the developers.arcgis.com site and go to the ArcGIS Runtime licensing section, you can read all about the licensing for deploying your apps with ArcGIS Runtime. And then a quick look at the roadmap. So one of the things we have been working on since we released the 100 release is better support for software rendering. So we know a lot of you are interested in deploying your apps in virtualized environments, virtualized desktops. And in the 100 release, we didn't support software rendering, which meant that your virtual environment needed hardware graphics support. So it needed a hardware GPU support within that environment. We've added support for software rendering. So when it detects that it can't find a hardware device, it falls back to software rendering. So the user gets a slightly degraded experience potentially. It's using more CPU resources because there's no GPU available, but it means that your app keeps running in that environment. So we're really pleased with that, and that's looking very promising at the moment. Visual Studio 2017 integration. You saw Morten using the NuGet packages within 2017 there, but the Visual Studio extension that's downloadable from the developer's site currently doesn't work within 2017, but we'll be working on that and releasing that in an update coming up within the next
The NuGet packages
months.
do integrate.
The NuGet packages, yeah, they work fine.
It's just the templates.
Yep. A simpler callout API, so showing callouts on the map when you tap on the screen on a feature, popping up a simple callout with a button for an action, an image for an icon, and then a title and subtitle. So a really nice callout API across the APIs. And then those are some of the specific .NET features that are on the roadmap. There's more cross runtime features coming up on the roadmap as well. So the toolkits becoming out of beta and becoming full product releases. Being able to take an entire map offline. At the moment, we support the ability to take a geodatabase offline from a sync-enabled feature service, and being able to take a tile cache offline from a tile-cached map service. But the ability to actually take an entire map offline with geodatabases, with your tile packages, with vector tile packages. That's a really nice feature coming up. Improved raster support. Full support for the dynamic layer capability on ArcGIS Server Map services. Improved labeling support as well, including support for the arcade expression language. Coordinate notation formatter for converting between degrees, minutes, seconds, or MGRS grids and geometries. And a number of new layer types or additional layer types, WMTS, web tiled layer, S57, and related tables, and lots more. So there's some really exciting features coming up on the roadmap this year. And there's a road ahead session today at 2:30, which we'd encourage you to go to hear more about the
we'll demo a lot of these
runtime
features in that session, yeah.
Do you want to, is it working?
Yeah, it's working. It's working. So I can see over there the performance looks pretty bad, but here it actually looks much better. But here I have my terrain, and I can really get to stick my head into the mountains and get a feel for the terrain. But I can call into the runtime just by looking at a spot and then say tap, and it's going to use runtime to do a geocode. Sorry, reverse geocode. I can actually click and go around, it's like get the address for these places, and they should actually be all correct. So it's just an example of how you can take the runtime and actually using something that probably wasn't initially intended for, but it actually works great, and it was a very simple piece of thing to add to the app, to the Unity app. Because Unity it's actually built on Mono, but it uses the universal runtime when it runs on the HoloLens under the covers. And since we're a universal app or a library, it just works that way. So.
All right, and we are in fact, we're 1 minute over time, but that concludes the session on the ArcGIS Runtime SDK for .NET this afternoon. Thank you very much for attending.
Thank you.
Thank you.